Okay, here's 4.2, writing equations in slope-intercept form. All right, so here is our slope formula that we're going to use to find the slope of a line if we have 2 points the line goes through. All right, slope-intercept form, that's what we're using in the last section, is y equals mx plus b. Point-slope form looks like this. So m is still going to be the slope, just like it was in slope-intercept form. And then this point, x1, y1, is going to be a through point. Okay, so let's try this out. So this says write an equation in point-slope form. So I'm using that new formula here. Okay, so I need to plug something in these 3 slots. All right, and this is going to be my through point, and then there's my slope. So I just plug those 3 pieces in. So I'm going to do y minus -1, and my slope is -2. That goes outside the parentheses, and x minus my x sub 1, that is 3. Okay, and now I wouldn't want to leave a double negative in my answer, so y minus -1 is y plus 1. And there is my equation in point-slope form. Okay, all right, so let's try another here. So this is, again, is going to be my x1, y1. So using the same formula. And let's see, the y sub 1 is 4. The slope is -2/3, and x minus 1. I'm plugging 1 in for x sub 1. No double negatives there, so there we go. Okay. On the next page, we're going to look at writing equations of lines from 2 points. So when we have 2 given points, we can write an equation. And there are a number of ways to do this, so this is just one of the methods. But no matter what method you use, you're always going to want to find the slope. Because it doesn't matter if you're using point slope or slope-intercept form, you're going to need the slope either way. All right, so if you're not given the slope, you have to find it from the info. All right, and then you're going to use the slope and one of the through points to write an equation in point-slope form. All right. Last step, if asked to write an equation in slope-intercept form, we're going to convert the equation by distributing to eliminate the parentheses, and then by isolating y. So we want to get rid of the parentheses and get y by itself if we need it in slope-intercept form, which looks like this. Right? Okay, so these ones we are going to write them in slope-intercept form. That's probably the way that you're asked to write these the most often. So I'm going to find the slope, and since I already have a graph, I'm not going to use the slope equation. I'm just going to think rise over run. So I'm going to use these 2 points that are marked. But if you didn't have 2 points that are marked, find any 2 points that are on the grid, like that look like they're at integer places. So here, to get from this point to that point, I'm going to go up 1, and then I'm going to go to the right 3. So that means my slope is going to be the point 1 over 3. Okay. And then I need the y-intercept, which I happen to have here. So if I didn't have it, I could go through all of these steps, but I can see that the y-intercept here is the point 2. So if I'm looking for an equation in y equals mx plus b form, I already have the 2 things that I need. So this is going to be y equals 1/3 x plus 2. Okay? And we can do the same kind of thing here. It's just that my y-intercept is a little bit harder to tell. It looks like it might be about -1/2. But I'm going to go through some steps to make sure I get the exact right y-intercept. Okay, so I'm going to find the slope in the same way I did before. I'm going down 2 units here, and I'm going to the right 4 units. 1, 2, 3, 4. So that means my slope is going to be some rise over run, -2 over 4, which would be -1/2 once I reduce it. Okay, I know that it's going to be around -1/2 for the y-intercept, but let's go through the steps that we were talking about before to to find out for sure. Okay, so I'm going to write an equation first in point slope form, even though my final answer is going to be in slope-intercept form. All right, so I'm going to plug in -1/2 for the slope. Okay, and then I want to use one of the through points. It really doesn't matter which one you use. You could use either one of these. I'm going to use this point, but you could use -1, 0. So I'm plugging in 2 for y sub 1, so y minus 2. I'm going to plug in -5, so I'm subtracting -5. That means I got a double negative there, which I'll rewrite as a positive. Okay, so now what I want to do is get rid of the parentheses. I'm going to distribute the -1/2. Okay, so -1/2 times 5 would be -5/2. And the last thing I want to do is isolate the y. So I'm going to add 2 to both sides. Okay, and I could just say +2 over here, but I'm going to want a common denominator, so I'm going to write this as +4/2. Because if I was writing +2 and I wanted a common denominator, I'd multiply it by 2 over 2. Okay, and then I'm really running low on space here. But now those will cancel, right? And I've got y equals, here, I'll write my answer at the top here. Y equals -1/2 x, and then -5/2 plus 4/2 would be -1/2. Okay, so if you just eyeballed it there and assumed that that y-intercept was -1/2, it would have worked out here like that. Okay, but sometimes it's a little bit hard to tell. All right, so let's try it without a graph. So I'm going to label this as my first xy pair, and this can be my second xy pair. And the first thing I want to do is find the slope. Okay, so I'm subtracting the y's in the numerator, 10. So here's my formula. Okay, so I'll do 10 minus 4 for my y's, and 3 minus 1 for my x's. That gives me 6 over 2, which reduces to 3. So my slope is 3. Okay. Then I'm going to write an equation in point slope form using the slope. So here's the slope. Okay. And then I'll use one of the xy pairs. And you could use either one. I'm going to use this one. So I'm going to do y minus y sub 1. So that's y minus 4. And then in the parentheses, x minus 1. Okay, and if I was asked to write an equation in point slope form, I'm done. But since they asked for slope-intercept, I still want to get rid of the parentheses by distributing the 3. Okay, and then I'll add 4 to both sides to isolate the y. So now y is going to equal 3x plus 1. And I've got it in slope-intercept form. Okay. All right, let's try another one just like that. So let's find the slope first. So I've got, I'm using this formula here, subtracting my y is -4 minus -1. That goes in the numerator up top, and then I've got 8 minus -4 in the denominator down bottom. So that's -4 plus 1 and 8 plus 4. So -3 over 12. And 3 goes into both those, so I can divide the top and bottom by 3, and I'm going to get -1/4. Okay, so there's my slope. Now I'm thinking, okay, I can write an equation in point slope form because I have a point and I have a slope. I actually have 2 points to choose from. Okay, so I'm going to use this point. Slope is -1/4. The x-coordinate is -4, so x minus -4. Okay, I want to take care of my double negatives in there, so those will become positives. Okay, and then I still need to get rid of the parentheses by distributing. Okay, and -1/4 times 4, that would be -4 over 4, which would be -1. Okay, and then I'm going to subtract 1 from both sides to isolate the y. So y equals -1/4 x minus 2 then. Okay, and you could use the same technique even if you do have a graph. You know, you could find the slope using the slope formula. But I just count rise over run when I can see the graph. Okay, on the next page, we're going to work with some function notation. So we're going to still write an equation in slope-intercept form. So I want my final answers to be in the form y equals mx plus b. Okay, and this says when f of 2 equals 3. So that means when my input is 2, my output is 3. In other words, when x equals 2, whoops, I was writing x because I was talking and writing at the same time. When x equals 2, y equals 3. When x equals 6, y equals 5. Okay? So it's the same thing as saying a line through these 2 points. So you can do it in the exact same way that we did the problems on the previous page. And that's totally fine. I'm going to show you an alternate way to do this. So what I'm thinking is, first I need to find the slope, no matter what method I'm using. So this part's going to be the same. So I'm going to use my slope formula here. I'm subtracting the y's, 5 minus 3 on top, and 6 minus 2 on bottom when I'm subtracting my x's. That gives me 2 over 4, which is 1/2. Okay? So now what I'm going to do with this other method, instead of using point slope form and then converting it, what I can do is use slope-intercept form. So far all I know is the slope. So it's going to be y equals 1/2 x plus something. So plus or minus something, because that b could be negative. So I still need to figure out the b. Okay? And I'm looking at these points, and neither one of them is the y-intercept, because neither of them have an x-coordinate of 0. But what I can do is just take one of those xy pairs. It doesn't matter which one. I'll use this one. And I'm going to plug in that for x and y into this equation. So I'll put a 3 for the y, and I'm going to put 2 for the x. And now I should be able to figure out what the b equals. And once I have the b, then it's going to be y equals 1/2 x plus whatever that b is. All right? So here I've got 3 equals 2/2 plus b. Well, 2/2 is 1, right? That would be 2 over 2. And then I just subtract 1 from both sides. So now b is going to equal 2. All right, and going back up to here, I knew it was y equals 1/2 x plus something. Now I know it's y equals 1/2 x plus 2. It's the same result you should get if you wrote it first in point slope form and then converted to slope intercept. I kind of like this method, but they both take about the same amount of time. So whatever your preference, it should work out the same. Okay, so this is saying when x is 3, y is -1. And when x is 4, y is 2. Okay, now let me separate this out a little. Okay, so let's find the slope first. 2 minus -1 for my y's in the numerator, and 4 minus 3 for the x's in the denominator. So that would be 2 plus 1. So I've got 3 over 1, 3 over 1, and that's just 3. So my slope is 3. Okay, so y equals mx plus b. Well, I figured out the slope part, so it's y equals 3x plus or minus something. Now I just have to figure out what the something is, and that's where I'm going to use one of the through points. Again, you could use either one. I tend to just use the first out of the two, but you could use the second. So I'm going to plug this in for x and y. And then I'm going to solve this for b. So I've got -1 equals 9 plus b. Now to get the b isolated, I'm going to subtract 9 from both sides. And that means -10 is going to equal b. So now I've got the other piece of information. Remember, I knew it was y equals 3x plus something. Well, that something is going to be -10. So y equals 3x minus 10. Okay. All right, next up. I'm going to look at a word problem here. It says you pay an installation fee and a monthly fee for internet service. The table shows the cost for different numbers of months. Can the situation be modeled with a linear equation? If possible, write a linear model that represents the total cost as a function of the number of months. In other words, they're saying this is going to be our input and this is going to be our output, so our x and our y. Okay? So first, just to check if this works with a linear function, I need to make sure that the x's are evenly spaced, and they are. We're counting by 3's with the x's there, right? And then I'd want to see if our first differences are the same. If we have a common difference. So I want to see, am I adding the same thing to get from y to y? So I'm thinking 176 plus something is 302. Well, I could just do 302 and subtract 176 from it. And that gives me 126. Okay, and then I want to check, okay, well, 302 plus 126, does that get me to 428? It does. And then add 126 again. That should get me to 554, and it does. Okay, so I do have a common first difference. So my first answer is yes. It does fit a linear equation. So let's write that linear equation then, okay? So what I'm going to do is treat these as xy pairs. So I've got 4 different xy pairs here. Okay, so I have more information than I need. So I'm really just going to use these first 2. You could use any 2, but I'm going to use these first 2. So I'm going to use those 2 first to get the slope, using the slope formula, since I don't have a graph in front of me. So my y's, I'm going to do 302 minus 176. And my x's, I'm going to do 6 minus 3. Okay. And I already did this subtraction on my calculator, actually. It's going to be 126, right? And then on bottom, I've got 3. All right, and then let's see if that reduces. And that comes out to an even 42. So my slope is 42. Okay, and now you can use either method. You could write your function in point slope form. You could actually leave it in point slope form because it doesn't say what form it wants it in, but I'm usually going to use slope-intercept. So what I'm going to do is use the method I was showing on top of this page. I'm going to take this format and plug in my slope first off. Okay, and then I'm going to use one of the points, the xy pairs, to plug into this to find the b. So I'll use this one. So I'm plugging in 176 for y, and I'm plugging in 3 for x. Okay, and 42 times 3 comes out to 126. Okay, and now I've almost got b. Let's subtract 126 from both sides. And b is going to be 50. Okay. And now I'm going back up here. Okay, I already had the m. Now I have the b as well. So this is going to be 42x plus 50. Okay, where x would be the number of months and y would be the total cost. So now if I wanted to know, if say I was doing this for 100 months, I would just plug in the 100 for the x, and then I could get the total cost. Okay. All right, that is the end of the section, and I'll see you next time.